All right, so buckling up, everyone. We're diving deep into quantum computing today. It's not sci-fi anymore. It's like happening now.
It really is. The progress is pretty mind-blowing.
Yeah, you sent over a whole bunch of articles on Google's Willow chip, their new quantum processor, and some pretty wild claims in there, solving problems in minutes that would take like supercomputers longer than the universe has existed.
It's causing quite a stir, and for good reason. It's a pretty big leap.
So before we get ahead of ourselves, maybe back up a bit. What is quantum computing? I mean, really?
Okay, so imagine a computer, right? But instead of bits, those zeros and ones, it uses qubits. And qubits can be both a 0 and 1 at the same time. It's called superposition.
Whoa. Okay. That's a lot to take in. How does that translate to actual computing power?
Well, think of it this way. A normal computer goes through a maze one path at a time. A quantum computer, because of superposition, can explore all the paths at once. It's not just faster, it's like a totally different way of doing things.
So it's not just speed. It's solving problems our computers can't even like begin to.
Exactly. And that's where this Willow chip comes in. It's a 70-qubit processor. Google says it's had a breakthrough with something called random circuit sampling.
Right, right. Random circuit sampling. That's a term that keeps popping up in these articles. Can you explain what that is and why it matters?
Sure. Think of random circuit sampling as like a benchmark test, really pushes these quantum computers, like a crazy complicated puzzle with, tons of possible solutions. A regular computer would take forever to solve it.
But a quantum computer can like cut through the noise using its special abilities.
Exactly.
Uh,
And Willow did it in minutes, something a supercomputer would take billions of years to do.
okay, so serious power. But these articles also talk about error correction being a big problem for quantum computers. How does Willow deal with that?
Well, that's one of the most impressive things. Quantum computers are like super sensitive. The tiniest thing can mess up the calculations. But Google says Willow has made a huge improvement in error correction, especially as you add more qubits.
So bigger chips, fewer errors. That sounds like a pretty major win.
Yeah.
But let's talk about what Willow can do. Are we getting like flying cars tomorrow?
Not quite. Right now, it's mostly testing and benchmarking, but Google is talking about future uses in like medicine, materials, AI, even energy. Lots of possibilities.
One article mentioned a new facility Google built like specifically for making these chips. It seems like they're pretty serious about this.
Oh, absolutely. State-of-the-art facility in Santa Barbara just for quantum chip production shows you how important this is to them.
And it's not just Google, is it?
Yeah.
These articles mention a global quantum race. Countries all trying to, get ahead.
Yeah, it's definitely a competition. The UK, for example, they've set up the National Quantum Computing Center, investing a lot in research and development.
So why is everyone so keen to be like the leader in quantum computing? What's the big deal?
Well, whoever figures out how to, really use quantum computing, they'll have a huge advantage. Scientific discoveries, economic power, even national security, it's a big deal.
It's almost like we're seeing the start of a whole new like technological age, possibilities we can't even imagine yet.
It really is an exciting time. Willow might not be in your phone tomorrow, but it's definitely a sign that the quantum revolution has begun.
So before we get too carried away, let's get practical. You said Willow is mostly for testing right now. What
Yeah.
does that actually, involve?
Right now, it's a lot of pushing the limits, running complex algorithms, testing ways to correct errors, exploring quantum entanglement. It's about gathering data, refining the technology.
So like experimenting, exploring,
Hmm.
laying the groundwork. But can you give us a concrete example of a test on Willow?
Sure, imagine trying to simulate a complex molecule. Crucial for drug development, but really hard for classical computers. Willow, with its ability to handle tons of data at once, could potentially map these interactions incredibly precisely.
So instead of years and millions of dollars on like trial and error, we can have quantum computers finding the best drug candidates like way faster.
That's the hope. Long way to go before we see that in practice.
Mhm.
But these early tests, they're generating a lot of excitement.
All right, so quantum computing is a big deal. Willow is a big step. There's a global race to harness this power. But before we get too hyped up, let's talk limitations. What are the challenges researchers are still facing?
One of the biggest is scalability. Even with Willow's advancements, building bigger, more complex quantum computers while keeping the qubits high quality, minimizing errors, that's incredibly difficult. It needs breakthroughs in materials, fabrication, control systems, you name it.
So we have this powerful tool, but it's still fragile and
Yeah.
hard to scale up.
Yeah.
What other roadblocks are there?
Well, developing quantum algorithms.
Mm.
We need the software, the instructions to actually use these machines. It's a whole new way of computing, so we're still figuring out how to, make the most of it.
So the hardware is one thing, but we need the software to unlock the potential. Sounds like it takes physicists, computer scientists, engineers, maybe even mathematicians, all working together.
Absolutely. It's a fascinating mix of disciplines, all pushing the boundaries of what's possible with quantum computing. It really is an exciting time.
Okay, we're back and ready to keep going with this quantum revolution. It seems like something big is definitely happening, but
Yeah.
like with any new tech, there are going to be some, bumps in the road.
Oh, for sure. We've talked about the tech challenges, but there's also, the economic and geopolitical side of things. People often forget about that.
Yeah, it's like think about the early internet. Lots of potential, but not many people predicted how it would like change the world. Could quantum computing be that big?
I think it's possible. Think about it. The countries and companies that master this first, they'll have a huge advantage. Medicine, materials, AI.
Yeah, the stakes are pretty high. We talked about the global race. Countries like the UK investing a lot. What are they aiming for?
It's not just about like building the best computer. It's about creating a whole ecosystem. Research, startups, a workforce that can, actually use this.
So it's a long game, recognizing that quantum computing is like a fundamental shift, not just a fad.
Right. And the countries that invest wisely now, they'll be the ones shaping, this new era.
Okay, let's bring it back to everyday life for a sec. We got a great question from a listener. They asked, what problems can quantum computers solve that our computers can't even like touch?
That's a good one. One area that's really promising is drug discovery. Imagine simulating how molecules interact at the atomic level, like with detail we just can't get now.
So no more trial and error, which takes like forever and tons of money. We could design like super targeted drugs.
That's the goal. Revolutionize how we treat diseases, develop therapies, personalize medicine. It could be a real game changer for, healthcare.
Wow, that's powerful. What about other fields? Where else could quantum computing have this kind of like huge impact?
Oh, lots of places. Material science is a big one. Imagine designing new materials with properties we've never, seen before. Lighter, stronger, more efficient. It could like change everything. Energy, construction, you name it.
So like changing how we build things, how we power the world, how we, travel. Pretty mind-blowing.
Right. And don't forget AI. Quantum computers could really speed up machine learning, leading to, much more powerful AI.
AI is already changing so much. How we search for things, diagnose diseases, everything. What would like quantum-powered AI even look like?
Hard to say for sure, but the possibilities are huge. Imagine AI that can solve problems in climate modeling, financial forecasting, even like personalized education. The potential is enormous.
But yeah, we got to remember quantum computing isn't like magic. It's powerful, but it won't solve every problem.
Exactly. It's about, understanding its strengths and weaknesses, finding the right applications, where it can really, shine.
So it's not just about building bigger, faster computers. It's about the algorithms, the software that let us actually, use this power.
Right. That's where the real innovation is. Figuring out how to work with these computers, how to translate our problems into something they can understand.
We've talked a lot about Google's Willow chip. It uses superconducting qubits. But some of these articles mentioned other ways to build quantum computers. Is there like a clear winner in the tech race?
It's still early. There are a few different technologies, each with, pros and cons. Another one is trapped ion quantum computing.
Trapped ions. Sounds like something out of Star Trek. How does that even work?
So instead of superconducting circuits like Willow uses, trapped ion systems use individual atoms, like suspended in electromagnetic fields. Those act as the qubits.
So you're like manipulating atoms to do calculations. That's wild.
It is pretty amazing. Trapped ion computers tend to hold on to quantum information for longer. That makes them good for some specific things.
But I'm guessing there are downsides too.
Of course, they can be slower, harder to build, harder to control, and scaling them up is still a challenge, just like with superconducting qubits.
So it's a race with no clear winner yet. Different approaches, all pushing the limits.
It's a really exciting time to be watching this all, unfold. The competition is driving so much innovation.
Speaking of breakthroughs, let's peek under the hood of this Willow chip. We've talked about what it might do, but how does it actually work?
Okay, so Willow is a superconducting quantum processor. It uses these intricate circuits, and they have to be cooled to incredibly low temperatures, like just a fraction of a degree above absolute zero.
Colder than outer space. Why so cold?
Well, at those temperatures, the electrical resistance in the circuits, it drops to zero. That lets the qubits, those quantum bits of information, stay stable and do their thing.
Sounds incredibly complex.
It is. Building and running a quantum computer is like a huge feat of engineering. It takes specialized equipment, controlled environments, a deep understanding of quantum physics. It's a lot.
And Google built this whole new facility just to make these chips.
Right. That Santa Barbara facility, it's a sign of how committed they are. It's a cutting-edge place. Special clean rooms, top-of-the-line equipment, all for making these delicate and powerful chips.
They're not messing around. And it's not just Google, IBM, Microsoft, even Amazon are getting involved, plus all the startups and universities.
It really is a global effort, and the
Yeah.
pace of innovation is incredible. New discoveries all the time. It's amazing.
It's a fast-moving field. But before we wrap up this part of our dive, let's step back for a sec. We've talked about the good stuff, but any powerful tech has potential downsides too.
Absolutely. We have to think about the impact on society,
Right.
the ethics, the risks, the ways it could, change things.
We mentioned cybersecurity concerns, quantum computers cracking our encryption, that kind of thing. That's a bit scary.
It is. If our current encryption becomes useless, it could have, huge consequences. Data privacy, national security, even the global financial system. It's something to take seriously.
So yeah, we're excited about the possibilities, but we also got to be, aware of the potential problems.
Right. It's about being proactive, thinking ahead. We need to anticipate the challenges, talk about them openly, and work together to, make sure quantum computing is used responsibly for everyone's benefit.
That's a really good point. It's not just about the tech itself. It's about how we use it and
Yeah.
making sure it doesn't, get into the wrong hands or have like unintended consequences.
Exactly. It's about shaping the future of quantum computing, making sure it aligns with our, values and hopes for a better world.
That's something to remember as we go forward. We've covered a lot, but there's still more to explore. We'll be back in a bit to wrap up our deep dive into the world of quantum computing. All right, welcome back. So we've explored the potential of quantum computing, but like we said, we got to be careful, right? Think about the bigger picture.
Yeah, totally. It's like we're stepping into this whole new world full of, possibilities, but also some potential pitfalls.
We talked about cybersecurity, but what other like societal impacts should we be thinking about?
Well, one thing people talk about a lot is jobs. As quantum computers get better, they could automate a lot of things that humans do now. Could lead to, job losses.
Right. Yeah. Automation's always been like a double-edged sword. Progress, but also, worries about jobs. How do we make sure this transition like benefits everyone?
It's about being prepared, investing in education and training so people have the skills for, this new quantum world.
So instead of being like scared of the robots taking over, we focus on helping people adapt.
Exactly. Quantum computing might be disruptive, but it'll also create like whole new industries and jobs, things we can't even, imagine yet.
Yeah, that's a good point.
Hmm.
Like throughout history, new tech has always, changed the job market. Got to be ready for that.
Right. And it's not just about like technical skills either. We'll need people who understand the ethics of it all, the social impact, the policy stuff.
So it's got to be a more holistic approach, right? Not just the tech itself, but like raising a generation that can guide this technology responsibly.
Yeah, exactly. Making sure quantum computing, serves us, not the other way around.
That brings up another important question. How do we make sure everyone benefits from this? Not just, a few people. How do we make sure it doesn't like make inequality worse?
Well, that's key. It starts with access. making sure that researchers, businesses, communities all over the world, can actually use these resources, not just a select few.
So it's about, like, democratizing this tech, making sure it's used to solve problems that help everyone.
Absolutely. And it's about building a quantum community that's, diverse and inclusive. People from all backgrounds, all perspectives.
Because the best solutions come from, bringing everyone together, tapping into all that creativity and ingenuity.
Exactly. The future of quantum computing isn't like set in stone. It's something we're going to shape together through the choices we make, the actions we take, and, our commitment to using this tech wisely.
So as we wrap up our deep dive here, what are, like, the key takeaways for our listeners? What should they be thinking about as this all, keeps moving forward?
Well, first of all, I'd say stay curious, stay informed. This field is like changing so fast. Keep learning, keep asking questions.
Be part of the conversation, right? Not
Yeah.
just, watching from the sideline.
Exactly. And don't be afraid to think big. Imagine what quantum computing could, unlock. It has the potential to revolutionize industries, solve some of our biggest problems, maybe even change how we, understand the world.
Dream big, but act
Right.
responsibly, right?
Well put. It's about embracing the wonder and the responsibility that comes with, exploring this new frontier.
So to our listeners, keep exploring, keep learning. The quantum revolution is here, and it's up to all of us to make sure it, leads to a better future.
Thanks for joining us.
And thanks for tuning into the deep dive. We'll see you next time.